let me start what is going on here. So our study you have already done. So we try to decide a few different titles.
Yes,
Yeah,
we have
these are what you
there
have.
is three titles.
Yeah, three possible titles, and it's not the issue for now. And I'm going to show the other parts of what you have done here, and then continue what you should do for the next step. Okay.
Okay,
Initially, you prepared an introduction, and we talked that, we discussed that we need to uh, take the important and focusing data about the people who are working on our area, and
and study here.
yeah, you try to take a whole picture and put some of the data here. We already talked about it, and we could possibly say that we understood some important persons about this area. For example, here I can see my friend, my old friend from MIT, Thomas Wierzbicki, Abramovitz, and those are the tough guys talking about the crashworthiness, etc., etc. Especially the actual crashes or bending crashes. They have many studies covering these issues. And at the final paragraph of the introduction, we gave some info about our study. Let me try to read it again. In this paper, Crashboxes has been investigated in the open loop form with some different W-shaped profile, because regularly the Crashboxes has got a closed loop.
Close it.
Yeah, closed loop like rectangular, circular, or hexagonal shape. So we have also checked this one in your thesis, but in the initial paper that we're gonna publish, I hope, inshallah, let's say.
Inshallah.
So we try to focus a significantly step-by-step development of an W-shaped profile. Every single detail of the W-shaped profile cross-section, let's say, actually impact behavior and simulation technique. So W-shaped profiles are evaluated through maybe some development needed for the text also. Through computer crashworthiness analysis, and the results are detailed step by step. To create a finite element model, an explicit solver named LSDyna is used and perform the crashworthiness analysis. Experimental work on a W-shaped profile we also done to validate the finite element calculations. The LSDyna program was used to finish the analysis. Experiment work has also been done for the validation of this finite element analysis. Comparison of experimental and finite element analysis is encountered with 3.28% error. So again, we are not correcting what you have done now. We just try to understand, or our group, research group, needs to understand what we have done before. Let me take a look the developments, design methodology, and finite element modeling. Let's start with a design of an open loop crashbox. What we have done: initial the design system, the CAD model, and because the open loop system has got some weaknesses, we need to understand by using these simulations and uncover the hidden parts of our study to compare with the closed ones, and we continue just a simplification of finite element analysis intro and our model. You created a Crashbox model. I'm talking about, of course, W-shaped one, open loop, and there is a drop plate that we have used in our experimental studies. Do you remember the weight of this plate, Ahmed? Is there any info here?
50 kg. No, the drop plate where the knot is there.
Maybe here.
No.
I remember, maybe we should add the drop plate's weight.
Okay.
Maybe the next step. I don't know. Did you give the info? Okay, no problem. You just take a note and we can see.
Yeah,
Okay.
I'm
I just saw here. It's able to hold 150 kilogram and drop it from 2.88 meters. Height with a maximum speed of 25 kilometers per hour. It just continues. Okay, we have the info, and this is the experimental setup of our university. What is this, Ahmed? Is this an info table about the setup?
Yes.
Okay. Then we need a title for this one.
Okay. It's just a table of one sample, because we have just developed the step of this table how to create the LS Dyna model. So we just discuss in one model of this our Crashbox.
Okay, let's continue the test setup. So you have taken out the all figures into one. Validation of finite element analysis. So we need some explanation here, maybe. We will discuss for the next meeting. Today's meeting is going to cover generally the development sales, detailed talks, let's say, detailed discussions. So results and discussion. Let me check. Yeah, you try to write something before. For example, let's start with figure 1. In this step, analysis has been started with default setting parameter of the LS Dyna with Fs is equal to 0. Fs, friction or failure? I don't
Failure strain.
Failure, right?
Failure strain.
Yeah, failure strain. Mesh size 5 millimeter per element, contact, single surface contact. Okay, there was a problem. You change mesh size. Okay, it is going to decrease. And in figure 3, failure strain, you have given 0.2, and the analysis started to show the procedure. But as I told you before, especially when you look at the edges here, 1, 2, 3, it just continues. I'm not talking about the open edges, just the buckled edges. So these have more strength when you compare with the open ones because of the cross-sectional moment of inertia, if you remember. And because of that, because of more strength that the system has got, when you push from the top, the Crashbox, especially the rib of the system, I'm talking about the edges, it's going to hold the system like when you trying to carry something. You just hold it and put into your shoulder and you are carrying it. I'm talking about the muscle system and muscular system and bone system, skeletal system. This one is giving us the edges, giving us the strength part of the Crashbox. It means it's going to hold more weight when you compare with the other parts of the Crashbox. For example, here, the surface, other surface. We have got 1, 2, 3, 4, 5, 6, 8 surfaces. It's against the movement of the drop plate. So the skeletal reaction system is the edge of the Crashbox. So we have got again closed inside edges, 1, 2, 3, 4, 5, 6 edges. Those edges have more power, more weight that is going to carry. It means if you have more weight and power, it means it's going to show us more stress. So when the stress is coming up to the edges, it is going to deform more when you compare with the surfaces. Because of that, when you give the failure strain, for example, 0.2, the stresses of the edges is more than the surfaces. This means the gaps here, which are the errors, that is not gonna happen in the real scenario. Those gaps shows us the simulation is going wrong. So we need to explain here why the gaps are coming up. As I told you, because the behavior of whole Crashbox, stress or deformation behavior, the regular surfaces reaction is less than the edge. So the failure point you have given 0.2, it's not going to affect the less stressed surfaces, but it is affecting the more stressed edges. Because of that, the edges are coming up earlier than the surfaces. I'm talking about the 0.2. But when you change it for the next step, let's look at it. For example, when you increase failure strain 0.3, you have seen that much more non-wanted, not needed, or not real deformation type is expressed by the LS dyna. So we try to understand what is happening here. And when you look at 0.5 failure strain, it's also continuous. It means that you understood from the steps here, I think, and you decreased it into the 0.1 because the failure strain is so huge here. Strain means percentage deformation over the length when you look at it. And 0.5 strain is a huge number. So, and again we understood from the results, it's not acceptable solution because whole of the material is gone. During the failure strain, what the LS dyna is doing, erasing the elements. You are telling the LS dyna that the failure strain of a single element, when you reach up to the point, for example, look at here, 0.2, you just gonna erase the element because of these gaps are coming from that. You increase it, try to understand what is going on. It is erased much more elements, so some of the other parts become free. Because of that, it just extra large deformed So this is meaningless. Shear, all of the surfaces, connection areas has got shear stress.
Disappear.
Yeah, and disappear. The edges disappear, so the surface become free, and it's just gonna bend and rolling up. Okay, but for the when you come to the 0.5, you understood exactly, I think. So you change it and come back to 0.1. And when 0.1 is applied, we cannot see any gaps here at the edges.
Any gap on the closed edges.
Yeah.
Just find the gap.
Yeah, longitudinal edges has got no gaps. So it means you try to understand the real behavior of the Crashbox. So you try to add something more, but you did not talk about these ones. But finally, at the final step of the development for the manuscript, I think we will try to explain all of the steps. But this one is the final one, which is so close to the experimental data, which you have given in the, I think here, okay? It is close one, not that one, but let me take the screen much bigger. Yes, here. The real deformation and LS-DYNA simulation result.
Yes, not so much differences.
Yeah. Of course, some of differences can be seen, but that will be acceptable. Yes, these are the regular explanations. So you need to express the deformation procedure by using the engineering
Languages.
Yes, engineering language. So you can say that, yeah, I increase the failure strength from 0.3 to 0.5 and I have seen this result. It means nothing when you send this explanation to the reviewer. Reviewer will ask you to talk about the every single details about the extra large deformation, damage, fracture, failure, and LS-DYNA application details. So, considering this one, our group and I try to find some books. So, I think I have given some of the books. But let me open it. And I'm going to again share the screen to you. Yeah. And time to time, I'm going to give some word to the NS to talk about the details, what he has tried to show us. He studied about a few days considering this one. Yeah, we have got a few books. I think these three books, you have the books, I think.
This one I don't have.
One of them, Shock, Impact, and Explosion. The other one, Vehicle Crashworthiness and Occupant Protection. But I think the most important document, Formulas for Mechanical and Structural Shock and Impact, from the Grigory Sulazinski. Yeah. Initially, I want to tell you how you gonna study.
Okay.
Yeah. We have the steps. You know already what you have done. The experimental data, experimental steps, manufacturing, etc. We are not dealing with the manufacturing.
Yes, we just dealing with experimental and
experimental, and one of the experiments. So we have got maybe more than 100, right? We have got more than 100 experiments. I don't really remember. But
yes,
the general behavior, we understood what is the behavior of the Crashbox, talking about the open loop and closed loops. So we try to understand the topics. How many topics you have? Topics means the issues. One of them,
buckling, failure.
yeah, something like that. But initially, all of this study covering the crashworthiness, shock, impact. So you need to find those type of books, papers, journals, movies, etc., whatever it is. We have done most of them. But the study, you need to write some type of important parts of your study. Write it down, step by step. First, we did this. First, after that, we did that. During this one, you will try to open up the details of the study. Try to understand what is happening. So, whenever we check about the shock, impact, etc., we have seen that most of the issues has got an connection with the vibration. So, some of the books are talking about the vibration and initially natural frequency. Look at here, for example. It is initially talk with the natural frequency of the elements. So, I'm continuing. It's not so important for us because our focus point is not vibration and frequency. Yeah, maybe in the future we can take a look, but not now. Okay, it just continues. So what I am searching in the books are or is the topic that I need first.
Impact.
Yeah, not impact maybe. Impact is one of them. Damage.
Yes.
Failure. Fracture.
Fragmentation.
Extra large deformation. Geometric nonlinearities and material nonlinearities. Okay, so in this book, let me try to find the details first about this book. Yes, we have checked it before, and for the chapter 4, 5, yes, they are talking about the initially vibration, and then the other important point is shock waves. The impactor or drop plate hit the Crashbox. The vibration occurred because of the shock waves. Shock wave is continuing. When you consider the Crashbox, drop plate is coming, hit, initial shock occurred, the system is vibrating, and this time, because of the shock wave and impact behavior, the Crashbox is changing its shape. It is deforming. But again, this one is not so important for us because our focusing point is changing. So, I am coming to the yield and failure criteria, chapter 6 of this one. Chapter 6 is very important. Look at here, because when you look at the extra large deformation, we have got yield. Of course, failure and huge failure. Theoretical outline. So I just captured this one. Chapter 6 is very important, yield and failure criteria. And the simulation is covering the explicit procedures. We have to know about the strain rate effects. Strain rate effects is very important. And because of that, we are using the dynamical behavior of the materials. So after that, we are jumping to the chapter 7, impact. That is our important part. I think one of the most important part, chapter 7. So chapter 8, when I look at here, chapter 7 is okay because it's talking about the parts, central impact against rigid wall, particle impact, body impact. It continues, peak impact force, rigid mass impacting an axial bar, for example. This one is very important. I'm talking about page 244. Rigid mass impacting an axial bar. And after that, axial bar width and end spring. This one is not so important because they used that.
Yeah, because we don't have it.
Yeah, of course. But especially page 244 is very important, but the other ones also taking the info up to the rigid mass impact. Because of that, the initial part also important. And when we come to the chapter 8, it is talking about the general collision of a vehicle. So we don't need to focus. We cannot use this one. It's not so important. Chapter 9 also, cables and strings. Yeah, we can erase it. Chapter 10, you can take a look at it. Beams. Yeah, we can say that these crash boxes can be said as beams, but has got some different shaped crash box cross sections. You can also take a look at beams. And chapter 11 is talking about columns. Yeah, we can say that these are columns, but when we look at the columns chapter, we have seen that it's not so close to our description. So
But here is buckling with columns is maybe important.
yeah, you can check it. We will maybe look at this one.
King of plastic members.
Yeah, and chapter 12 is very important. Plates and shells. It's given many different things. Look at here. Inelastic range, static collapse load, under pressure loading. For example, the simplest part maybe before our study. And some different shapes. And chapter 13 is talking about explosion. You can pass it. Penetration, perforation, you can pass it. But chapter 15 is very important. Damage, failure, and fragmentation. Okay? So, let's start with chapter 6 here. Yes. Yield and failure criteria. This is basic consumption, which you can remember from the strength of materials, mechanics of materials. Basic theories. Morse theory, von Mises theory, Tresca. These are general applications. And in page 218, you can see strain rate effects on smooth material samples. Strain rate effects. Look at here, the formulas. You remember, strain rate is here.
Yes,
Epsilon dot.
we are using the same thing.
So we can say that epsilon dot is the speed of x epsilon. Because when you look at here, u dot means v, if you remember from the dynamics. When you look at the length of the material, there is a kind of displacement during deformation. It is deforming, and this deformation is in a very short time. It means it is so fast, so you can take the speed of the deformation. Strain rate means that. So deformation speed over the initial length. So you can put this one into the equation. The initial study of the explicit deformation used by Cowper-Siemens. You can see the equation. For example, when you talk about the deformation, you can talk about the strain rate effects. Cowper-Siemens parameters. What is Cowper parameter? What is Siemens parameter? These are very important, Cowper-Siemens parameters. You can talk about this. But we did not use only Cowper-Siemens one. Maybe the other things that you consider, material models. For example, not just material models, equation of state, Johnson-Cook model, Steinberg, Grenadian parameters. You can write these down, and maybe during discussion you can say that yes, the LS-DYNA software used Cowper-Siemens in this one, but if I choose, or if I have chosen for example, Grenadian or Steinberg, if it is applicable, I don't know. Because, for example, Steinberg or Grenadian, sometimes they are using for ballistic impact. Maybe it's not applicable to this area. Okay?
Yeah. Near to Johnson-Cook.
Yeah. Johnson-Cook, right. Johnson-Cook model can be.
Johnson-Cook is very near to
So, you need to talk about these formulas, these detailed parts. For example, look at here. Most authors are 1 over S as a unit of strain rate, which makes the coefficient D 1,000 times larger. D is equal to 40.4 for mild steel. It is giving some info to you also. Ductility here. So when you look at the material that we have used, steel. What type of steel? It's not so tough one. It's a kind of mild and hard. It is between them. So you can give a kind of info, and you need to talk.
We can simulate to mild steel.
You should talk with NS after. For example, every day. Maybe afternoon or evening, I don't know. For half an hour, you should talk about step by step. For example, for the initial one, we should talk about the Cowper-Siemens and Johnson-Cook. What are the effects of these parameters can be for every single segment that you have put the figures on. You can talk about it. And strain rate effects. Let's continue. Balanced material concept. It continues. Strength of notched elements. We are not using notched elements. So this is not our area. Strain rate in concrete. No need. No need. Maybe you can check the examples for some equation applications, examples, I don't know. But this chapter is something like that. Let's continue with chapter 7. This one is the important topic. Central impact against rigid wall. This can be for our study. And look at here, but this is a kind of, the wall is, I think, steady state. The other part is moving. It's not so important for us because it's a kind of impulsive effect. So you can also check what is going on here, the equations. NS is also, take a look at these equations. Particle impact against a rigid surface. It can give some idea because our structure is not a particle, it is a rigid system initially for considering from the dynamics, but not rigid body dynamics. It is changing, it is the shape. Because of that, we have to look at the failure part again. Body impact, frictionless surface, we have got friction. You can take some idea, data, maybe little equations from here and put in an order by using the descriptions here and adapting those descriptions into our study.
Try to relate to this description to our study.
Yeah. It's a similar thing. Okay. And I'm just continuing. Body impact against non-slip surface. It continues. Body of revolution. Sometimes we have got revolution, but not like this. During bending, the vertical edge become a bended edge. Because of bending, the edge is rotating. Okay? When you look at here, when Dropbox hit, the Crashbox is bending. But what is happening? The edge is rotating. You can come up with that kind of idea. I don't know. It's up to you. Peak impact force and duration of impact. This one is very important. This guy is adapted to a perforation, a ballistic impact, but it's not so important. You can think that this is Crashbox, this one is drop plate, but our drop plate is rigid. Okay, local deformation formulas for elastic contact. Yeah, initially we have got elastic, but after that it is changing its shape. So you can say that, for example, during the impact, the initial phase is elastic contact. You can give some ideas from here. Not all of them. Maybe just some words, not the equations. Because I'm telling you these behaviors, equations, paragraphs, etc. for all of the papers that we plan to publish. Maybe we plan 3 or 4 papers, you remember. Yeah, you should not use all of these equations into just initial paper. You can take some of them, put some equations, try to give away, try to give a path to explain the details of what we have done. You understand? We also,
Yes,
with NS, try to write something, take the equations and give away, but you should also study something and you will take the data that you have done and NS and I take it out. You should take them together and most of the part will be finished, I think, after that. So let's continue.
Okay.
Elastic parameters of impact according to the Hertz theory. I don't know, maybe you should read here. But my advice is you should read chapter 7 from beginning to end.
Okay.
So it is going to give you an idea of what we gonna next for all of the steps. For every paper. The other papers also. Look at here, elastoplastic contact and perfectly plastic contact. It also has given these info too. Rigid mass impacting, as I said, this one. This is the main focus area of this study. Look at here. So maybe just this one will be enough for the initial paper.
Yeah, I explained these things in the papers. Maybe
Yeah,
I don't
look at
know, but I explained
you can talk about these formulas. When you are explaining the details. For example, I changed the strain rate or failure strain. What is affected by changing the failure strain? You get it? You need to find that formula from the theoretical manual of LS-DYNA. When you change failure strain, what is happening? Which formula is using the failure strain parameter, for example? You can focus on that one for the initial paper. And you need to find that formula. Yes, continue. Tabulation of cases. This one is also important because the guy, let me find his name. Let me remember him. Yeah, Gregory Suzuladzinski. This guy is created a very well done written book. He tried to express the info by applying it to the applications, like an example. Look at here. And it also gives every single detail for the problem. Look at here.
but it's a different problem. It's a
Different. But you should take a look all of the cases and maybe you can find some similar parts, not all of them, some similar parts. For example, viscose damping. Of course, you don't have any viscose effects, but you can think that yes, when the Crashbox is bending, buckling, it is kind of a absorbing system. It is not a viscose damping, but it is absorbing the energy. For example, this one. You see, cylindrical striker impacting an elastic surface. Yes, our roles are changed. Not elastic surface, okay, but cylindrical striker. Our crash box is this, and drop plate is this. You can think something like that, but this is a rigid one. Continue. Look here. Look here. Especially case 7.23, 24. These are just so close to our study. You see?
Yes.
Okay. And again, look at here. But this one is hitting a kind of nail into the soil or something like that.
Yeah, it's making a hole, like piling things.
But these two guys are very close. You can use the equations development.
Okay.
A hard striker with cylindrical contact, deformable. So this one is a little bit different, 7.27, but it is not so far. When you hit, the cylindrical part is deforming like that. You understand here? It's seated and the diameter is expanding, increasing here. It is cylinder. After the heat, it is become a cone. Conical behavior. Continue. The most important part for this book is it is giving some cases, some examples. Look at here. It is close, not the same, but close. Okay? So I'm taking chapter 10 now. It is talking about the beams. Yeah, of course, beam is not so close, but we can say that our cross section is different. We can accept it as a beam. In that position, you can use these applications also. But of course, you should look at the title, heading that you needed. This one is generally talking about the classical beams used in strength of materials, and something is hitting to beam. Not the same approach, but you can take a look at it, as I said. Let's continue a little bit more. Again, some cases you will check. I'm going to jump into chapter 12. Plates and shells. This one also is important. Look at here. This is a stress-strain relationship. General deformation. You can give some info. If you applied a surface material or shell during the simulation and we used shells, you can say that we can accept this formula during the elastic deformation. You can give this one also. But after elastic thing, the plastic behavior will be explained. If you can find here. Shear plate. Look at here. This one is talking about elastic range. Transient, it means it is dependent with time. Mass plate impact forces. And the yielding is started. Internal forces and yielding started. You can look at here also. Inelastic range, it is the inelastic range started. Static collapse, not our study, but it can give some idea. For example, you can say that during the inelastic range of a static collapse, something like that, we can use these formulas, but up to our study, it is a dynamic deflection under pressure. Okay? This is what we are focusing on again. Page 519. Siz de not alıyorsunuz değil mi? So let me continue. Look at here. Cylindrical and spherical shells. long pressurized cylindrical shells with no end constraints. This is a little bit different, okay, but you can take some words from here. Cylindrical shell with axisymmetric load varying along the axis. This is also close. You can say that, okay, this one is talking about the cylindrical, but you can take the scenario by changing it using the W-shaped ones. Fixed and cylindrical shell under pressure loading. This one is much closer. But okay, this one is internal pressure. Static collapse. And you should look at the, again, scenarios, cases, if you find a close one. Look at here. You see?
Yes.
This one is very important. Hinge production. So, because our shape is not perfect and also the closed ones has got no trigger mechanism, we have got a not perfect hinges. Here, the guy has got a trigger system, I think. When you push down, it is creating a kind of rings. So, one hinge after one hinge, many hinges. You can use this chapter also. This case, I'm sorry. Thin wall rectangular tube. Again. The deformation is different. Okay. Buckling. This one radial, but when you push from the axial side, it's going to create some radial force also. You can talk about here. So finally, one more chapter. Damage, failure, and fragmentation. This one is talking about the shear, deformation, damage. It means extra large deformation. Pressurized rings and shells, static versus dynamic breakup. It has talking about maximum number of fragments from experiment. Wave reflection, stress waves. This one is the important part for our study also. Failure of beams. You can talk about with this one. Crack propagation. Of course, this material is not so open to the crack propagation system because it is exactly buckling, creating hinges, bending, and not creating a crack propagation. So maybe you should not look at so much. If the sheet has shown a kind of tear, so you can look at the crack propagation. Progressive collapse, look at here, page 650. This one is important because our system has got a progressive collapse and equations that is used here. Rock breaking, this is not our issue. Continue. Explosive, continue. Compressive strength, continue. Boulder breaking. Yes, and let's look at a little bit to the cases. Look at here. This one can be page 674. Breaking of a cantilever tip due to impact by a square block of mass m. It is kind of pretty straightforward. It can give some idea. Metal cutting. Going a little bit faster. Yes, explosive, etc. Okay, Ahmed, I think you have understood what I am talking about, right?
Yes, yes.
Let me try to find another book which is very important to us. Okay, I have found the book Vehicle Crashworthiness and Occupant Protection. This one is coming from American Iron and Steel Institute. We also offering this book and Formulas for Mechanical and Structural Shock and Impact, this book, and Shock, Impact and Explosion. You should buy these books for studying these areas. Okay, if we look at the second chapter of this book, Design of Vehicle Structures for Crash Energy Management, this is also so close to our study and especially describing every single detail by using flowcharts, folding, clipping, bending, hinge mechanism, etc. So if we come here, it is talking about the whole vehicle system, describing each element as a kind of spring. Look at here, box, torque box, front frame, drive line, every single element. It is describing the elements by using springs, because when the sheet metal hits the wall, it's going to bend, buckle, fold. This behavior, Kamal's model, is going to define the energy absorbing system. So it is again describing the steps. Look at here the suggested model of substructure. This is covering crash boxes again, all of the vehicle frontal structural parts. So I'm going to talk about again here, after crash, the hood of the vehicle and absorbing systems, all of the structural parts are collapsed. There is a collapse occur in here. Let me continue a little bit faster. Hinge mechanism is very important. Super collapsible beam, it means a kind of crash box. Dynamics effects, some equations about it. Analytical design here. Absorbing system. It is also used here a Kamal's model, something like that. Collapse modes. This is the important part. Axial collapse, hinge formation, and the mathematical model. This is also bending. This one hinge formation, this one bending and hinge. The equations of it, some empirical relationships and formulas describing it. When the sheet metal is thinner, the buckling is not a smooth way. The buckling creates a kind of non-smooth, a very different type of modes here. But when the thickness of the bar is increased, you can face with much more smoother collapsing, hinges here. You can see yielding stress, critic stress, etc., etc. Some local deformations. Crippling is also important. This one is formation of a plastic hinge and moving it when hinge occurs, and after a moving system we can realize it. Look at here, we can find the progressive folding here, angle folding, T-fold, Y-fold, and traveling hinge system. Some basic descriptions of it, and energy, defining the energy because of the absorbing the shock energy of the impact scenario. Bending collapse of mathematical models, these are very important also. You can face with different buckling or bending impact results. Again, load deflection curve, this is very important. Load deflection characteristics of a plastic hinge. I'm talking about page 64. And the equilibriums, talking about the details. Comparison, effective width formulations for compressively loaded, simply supported plate. This one is also important. Moment rotation characteristics. And the basic definition of a hinge mechanism. Yield lines. We should look at these ones in a very detail. Yield lines. Combined loading. It just continues. Design of substructures. I'm talking about the Crashboxes again. Look at here. Elastic stage, buckled, crippling, and folding. You can understand the behavior from the shape. Thin-walled finite beam element. This is very important. Page 80. When sigma critic is bigger than sigma yield, and this is also talking about the rotations, deformation, angles, typical thin-walled component, and after the deformation you can see the failure mode, bending crash mode, axial crash mode. And if we look at the system, considering the whole car, you can solve the equation by using conservation of momentum. Impulsive effects, if you don't have any impulsive effect, it is a kind of conservation of momentum. After that, the kinetic energy application, it means conservation of energy, initial energy, and final energy should be equal. Total energy, internal energy, we can say. Analytical tools and conclusion. This chapter is very important, and the third chapter talking about the FEM analysis, technical approach, formulation of the system, discretization. I'm talking about the meshing for explicit FEM. This is talking about the explicit formulation, strain rate effect, spin effect. And explicit integration is talking about the length over sound of speed. This is explicit integration. And shell element, plasticity, classical plasticity rules, yield conditions, and again we face with it's saying that rail test we can accept it as a Crashbox components. It's just given substructure models, deformation systems, and summary. So this chapter is okay. Let me continue with the third book. Ahmed, are you there? Yeah, if we look at the last book, Shock, Impact, and Explosion, we try to find some chapters which is close to us. One of them is Basic Structural Dynamics for Impact, Shock, and Explosion. When we look at when we look at the basic structural dynamics for impact, as I'm repeating it again, shock and explosion, this book's third chapter is important because when you look at it, it is explaining the system impact behavior starting from the fundamental behaviors. General information, single degree of freedom, unclaimed free vibration. In the beginning of our description, we have said that our study starting with the vibrations, because shock is creating a vibration inside of the system. So this one is trying to explain the vibration systems, some vibration equations. Initially, method 1, Newton's law of motion. The second one, it's talking about the energy method. You can find these approximations inside of the dynamics books, some of the dynamics books. It continues, and I'm not focusing on vibration as I told you. So after that we will have the, let me see, still vibration issue is continuing. We won't deal with that, but it is important. Because of that, I said if we try to see the very detail of the approximation, we should focus on try to understand every single aspect of the vibration also. Because of that, this one is important. So we should look at the chapter in detail, but in our approximation and paper that we're gonna write, we won't deal with the vibration systems. Okay, after that, chapter 4 is important, shock and impact dynamics. And especially for us, chapter 4 is very important, but chapter 4.5 and 4.6 much more important. Let me continue. The general behaviors, some special cases, for example, impacts and collisions of vehicles. This is a general behavior, and it is trying to define the problem by using impulsive effects. F is multiplied by time. So let's continue. Oblique impact, maybe when we gonna before oblique impact, we can find a kind of equations which is so close to the something hit to the wall and respond back. It's a kind of that equation. Again, talking about the impulsive behaviors. Bouncing, let's say bouncing. After that, oblique impact. If we talk about the crash boxes, sometimes you can face with oblique, with an angle, let's say, angle impact. The guy is talking about the oblique impact of the systems. For example, 4.3. It's very far from our structure. Aircraft impact. This is not our issue. 4.4 again aircraft. We can pass it. Yes. We said that 4.5 is important. Let me try to find it. Yes. Impact due to dropped weights. That is close to our representation of a crash box. Impact on piles and foundations. Of course, foundation is not our issue, but pile can be applicable. The equations. Yes, this pile you can dig it into the soil, but the basic manner can be describing our issue. Classical or rational pile formula. Of course, it's going into the soil or concrete, whatever it is. But the impact time, contact behavior, and some equations can be okay. And 4.6, impact on concrete and steel. Concrete part is not important for us, but steel part is our description. So we can look at the equations here. Different methods you can see in here for different applications. But you should read and understand what is it for. This one is talking about missile. Of course, we are not dealing missile for this study. We can pass. Rocks, we can pass. Water surface. That is not, again, our issue, so we can pass off also here. Snow ice impact. Yeah, this one is here. Analysis and modeling. Shock response of ceramics. No, it's not our issue. But you can find some type of words, some type of applications, which is okay for us. You can take also those info from the other parts and write it here. Maybe this one, shock impact load on the container. Yeah, of course, container is different, but the application, if you accept it as a rectangular shaped material, you can find a way.
So,
for example, when you continue for checking the book, you can find some different things, but you should look every single page sometimes to understand what is it inside. For example, impact tests. We have already know some of the impact tests, but some of them can be different. Bird impact, of course, different. We are not dealing with that one. Material modeling and finite element analysis and results. This one is important. 4.16.4. And very important. Why? Because this table table I'm talking about, 4.28, page 662. It is talking about explicit finite element, nonlinear integration scheme, all of it, by
It's the same as
algorithm.
it is our.
This one is very important, talking about the explicit finite element nonlinear integration algorithm, step by step. You can use this algorithm for creating an code, for example. And the table continues. Because of that, this table is very important. Look at here. It is inside the bird impact on aircraft, but we have found very, very important table. If, for example, you can say that I'm not dealing with the bird impact, so I don't need to check this chapter. But if you don't look the pages, I'm talking about all of them, you won't find this table. This is an important table. Let me continue again. Material data and modeling. This one is also important. 4.29. How are you gonna model the material data of the explicit system? Of course, this one is talking about an example, but it is also trying to give some info about the procedure. For example, composite shell specimen. It is given the composite layers, directions, forces, material data, stresses, Young modulus, Poisson ratios, everything. Let's continue. And this one, 4.16.5, Elastine gap contact elements. It is giving so many details. Contact algorithms, contact mechanisms, and some graphs that you can apply with your apply on your study. Pressure against relative specific
But this is
volume.
the bird impact data on the result.
Yes. You can apply, change the change. For example, instead of bird impact.
Where I can use this in this paper in.
No, I'm talking about some ways that you can contribute to our study. For example, here, stress strain. Okay, we look at here. It is using strain rate, and this is Cowper-Siemens. This is using Cowper-Siemens parameter again. And as I told you here, relative specific volume. Why? If you try to understand specific volume of the system, considering the pressure, you can understand the weight of the system. You can understand the weight and pressure, how you gonna adaptate it or change it up to your system's behavior. For example, I can say that you should talk with Ömer, and he's also dealing with the specific volume, etc. So you can create a connection with these type of graphs and our study. And we can also find many studies giving some info about the specific volume. Look at here, damage, stress strain curve for light alloys in the aircraft. We are not using aircraft, we are using Crashbox, but stress strain, of course, there is no difference with here. Force time. Okay, let's continue. And these are the final one is talking about bird striking. Okay, let's pass it. And chapter 6. Chapter 5 is generally explosion dynamics. We don't need to look at it. Chapter 6, Dynamic finite analysis of impact and explosion. We won't look at the explosion, but impact is our issue. Finite element equations of describing the system. Let me look at like that. General elements, isoparametric elements. This is then general info. It continues. And it is going to be applied to the force displacement system. Classical energy equations. Maybe we can find it in many books, but I can tell that you can see it in the Visual News Finite Element Method book also. You can find the approximations as an example, let's say. The general description of finite element model development. And this one is also very important. The development of the matrices, material matrix. This one is material matrix, compliance matrix, and the book is given that info as an open form. Everything is given here. Very important. If we're gonna deal with the equations in detail, you can get some info from these ones, from these tables. Again, this one. Young modulus, variable Young modulus, and Poisson ratios for concrete. That's not important. You can adaptate these equations up for different materials. You will change the numbers, etc., and you can use it for different materials. Bovine, steel, composite, concrete material properties. It's just given step by step. For different applications. For example, if you look at bovine, the three-dimensional data is given for the axis 1 Young modulus, axis 2 Young modulus, axis 3 shear modulus for different surfaces, and Poisson ratios for different surfaces. And different materials again. Many applicable values are also given. The tables, because of that, very important. And let's look at here 6.3 steps for dynamic nonlinear analysis. We are just inside of this title. So the behavior and description of the equations. Buckling state and slip of layers for composite sections. Of course, we are not using composite. When you are not using composite, the material will be isotropic, so it will be much more easier. Strain rate effects. This is important. It continues, again creating the tensorial definition. Stress vector, strain vector, and material matrix. Sometimes stiffness matrix, sometimes compliance matrix. And this one is also covering some nonlinear deformations, nonlinear descriptions also. Concrete, we are passing. Band propagation, blunt crack. I don't know, you can check this one also. Because detailed info is given, it's going to give you some ideas. Failure modes. 6.4 is different. We can pass it. High explosions. We can pass it. Now let me check 6.5. 5, 6 pass. But again, high explosions. We are not using high explosions, but in the future, if you're gonna study, these tables will be helpful. Spectrum. Solution procedures. Yes, 6.8 is good enough. Time domain analysis. Dependent with time. This is important. Frequency domain. It can be some different things. This one is also important, 6.9. Direct iteration, incremental method, Newton Raphson. These are also old methods, numerical methods. Newton Raphson solution and some examples. Explosive. 6.10 is not for now. Force or load time function. This can be important. The graphs. Finite element mesh schemes. This is also important. How you gonna mesh? When you're talking about the details, when you change the mesh, what is happening? You can get some idea from here. Hexahedral elements, beautiful behavior. Tetrahedral elements, bad behavior maybe. Yes, I'm talking about the A. This is chapter A. This is giving some additional info. The other ones are not for us, let's say. But steel and composites. Now we are dealing with steel. In the future, we are going to deal with steel, but composites. Steel, for us, let's look at the some known properties, values, some equations, some applications, some graphical descriptions. Look at here. Hammer drop on steel plates. We are not dropping hammer, but steel plates are moving to some Crashbox. The issue is not so far. We can adaptate some of the things. A.2. This is for composite structures. This is not for now. But in the future, we can get some data. But A.3, impact analysis of pipe rupture. Maybe we can use some data from here. This is for bending impact. Let's continue. Pipe whip analysis, it said. Explosions, let's pass. Steel domes, car impact and explosion. Car impact. General description. Finite element analysis and results. A.5.2 also can be checked. Yes, concrete structures and the other parts will be different. So Ahmed, we are close to finish. For a kind of study, you should take some books, some papers, some journals, whatever it is. We have just checked 3 books, and it has taken so much of our time. But for the future, it is a very helpful thing, because we will shorten next periods by spending enough time to understand what is going on in the science books and papers. We understood, we have tried to check step by step every single title, heading, chapter, etc. We have taken some notes, and we will take the notes, get them ready, put in order every equation, needed equations, some pictures, figures, some words, some paragraphs, etc., etc. And when we get the order, we will take some important parts of them and write maybe 1 or 2 pages, not more. But for the other papers, we will maybe increase the details of the equations. Okay? Okay, something like this.
But we have completed this paper, then we will continue.
Yeah. That is for the next steps. But initially, we will have 3 books, not more. And this one, the final one, is I think the last one. The initial one, formulas and vehicle crashworthiness. These 2 books are the most important ones for our study to describe it. Okay? Okay, let's finalize this class. I think whoever study for his area, he will understand what he's going to do for the next steps. When he puts everything in order, he should write every single thing in steps. And when he finishes first one, he will jump into the second one. If you don't write the steps of your study, you won't know what will be the next step. Okay, today the class is over.